So this problem says use given values and the fundamental identities to find the 6 trig IDs. So the 6 trig identities are sine, cosine, tangent, and then I can use the reciprocal identities to get these. What's the reciprocal of sine? Cosecant, cosine, and tangent. So this is what I need to find. Now, it tells me a clue. Sine of theta is 15 over 17. So I already got the first one. Now my second clue tells me cosine is what? What does it mean to be less than 0? It's negative. So where is cosine negative? Quadrants what? It's positive here, right? So it's gonna be here in these two quadrants. Now, remember, don't be tempted to use the triangles. You can use the triangles to check your answer, but it's telling us to use the fundamental identities. And this is a similar question to the one on the back side of your quiz that you'll see later on. Okay, so which identity do you guys want to use to help me find the rest of this? What would you use with sine and cosine? Which identity? The Pythagorean identity. Which Pythagorean identity? Sine squared plus cosine squared equals 1. And we're just going to put in sine now, substitute it. So now I have 15 over 17 squared plus cosine theta squared. And now I'm going to turn 1, I'm kind of thinking ahead. So 15 squared gives us 225. 17 squared gives us 289. So the reason why I didn't write the 1 over here, because think ahead, we're going to have to subtract. Does that make sense? So you could turn this, how do you turn that into a fraction? 1 over 1, and then essentially you're multiplying numerator and denominator by 289, right? Because this gives you the 1 that you need, so 289 over 289. What do we do next? We're going to subtract 225 over 289. And then we're going to have this cancels. You're left with cosine of theta squared equals 289 minus 225. 64, 289. And now I'm going to take the square root. Now be careful. This is where a lot of you guys made mistakes. When I take the square root, it has to be both plus or minus. So cosine of theta equals plus or minus the square root of 64 over the square root of 289. Remember, you're taking the square root of everything in the radicand. So cosine of theta equals, now cosine is supposed to be what? Positive or negative? Does that make sense? Why they have that clue there? I'm not going to accept the positive. Square root of 64 is 8, and square root of 289? 17. So there I have an answer. Okay, there's a couple of ways to get now tangent. What do you want to use? These numbers were pretty big, right? I could use tangent squared plus 1 equals secant squared, right? I'd rather use a quotient identity because I just have to work with these two fractions here. So tangent of theta equals sine over cosine of theta. And now I'm just going to do my substitutions. Sine here, 15 over 17. Cosine a big fraction line, 8 over 17. Now we're just going to turn our fractions sideways and not touch the fractions themselves. 15 over 17. 8 over 17. Class that becomes multiplication, so this stays the same. How about this one? 17 over 8. And if you simplify it, what do you get? Tangent is 15 over 8. Now let's think about this. Oh, my cosine should have been negative.
Love math. You don't love math? What's wrong with you?
What do we know about quadrant 2?
I love math.
Sine is positive, so I know this is going to be positive, right? And you could just use the reciprocal identities, and you don't really have to. I'll just show you one. You don't have to do them all. So for sine, I want cosecant. Cosecant of theta equals what? Reciprocal identity. 1 over sine, yeah? So this would be 1 divided by sine is 15 over 17. Change that to multiplication, take the reciprocal, 17 over 15. Those are both positive. Now, you could just take the reciprocal of those. So what is secant going to become? Negative 17 over 8, right? Because cosine is negative. There's my mistake. Cosine should have been negative. So I have a positive divided by negative. That should be negative 15 over 8. And that'll give me negative 8 over 15. So in this problem, to summarize, think about what they start with. Think about the other identities you need to find. Well, what's the relationship between sine and cosine? Use the easiest one, the Pythagorean identity. Again, once you have sine and cosine, how do you find tangent? Well, the easiest identity could have been quotient, or you could have used the Pythagorean identities, and you can easily just use the reciprocal identities to find the other three trig functions. Question? Yeah, so that's, once you guys watch the quiz correction video, use the fundamental identities. That's drawing triangles. So if you're going back to the x over r's, the a, b's, and c's, and the Pythagorean theorems, that's drawing triangles. This one I specifically want you to be using the fundamental identities. Okay? That's why in some of your quizzes you guys got marked down.